All right, and with that, I am going to hand over to Dima to talk about the resources at the OLCF, and then there'll be a discussion of the resources at the ALCF.
Thanks, Catherine.
Thank you.
So we'll go on with resources and Oak Ridge, which is represented by Summit Supercomputer. So you're probably already familiar with that. It has been running for a few years now. It's an IBM machine consisting of 4,608 nodes and accumulated peak performance of 200 petaflops. On a node level, we have obviously heterogeneous nodes with 2 IBM Power 9 CPUs, and they're paired to 6 NVIDIA Volta GPUs. This results to a node performance of 42 teraflops. So it's a very powerful nodes in a kind of compute power, but they also have lots of memory. We have DDR memory amounting to 512 gigabytes, and on top of that, we have also GPU memory, 96 gigabytes. Additionally, there's also non-volatile memory, and if you choose to use that, you can have additional 1.6 terabyte of memory. So the CPU and GPUs are connected through the NVLink 2.0, and the nodes are talking to each other through the Mellanox dual array infinite band interconnect, which is organized in the FAT3 topology. And we also have, of course, the file system, GPFS, which is 250 petabytes, which is mounted to Summit. So we also have a very good user guide, so you can read all the details there, and the link is at the bottom of this slide. So next slide, please. Catherine, next slide. Okay, so we talked about the hardware, now about software. We have mature and diverse software installed already for our users. And this is just a representation of some of the software which is already installed and supported. Obviously, if you have something more exotic, we'll always try to accommodate your request. But just to give you some general overview of things already installed, obviously you have compilers to compile your C, Fortran code with OpenMP or OpenACC or CUDA, so we all have that. And examples are obviously IBM Excel, but also PGI and LLVM, and of course GNU compilers and NVIDIA. We have a vast majority of different libraries to support your like math-heavy code, and we have ESL from IBM. We have fast Fourier transform and then linear algebra through Scalapack and BLAST different levels, and you have PET-C, Linux, NV BLAST, and other NVIDIA proprietary libraries like Q, FFT, QSparse, and so on. For the debugging and for developing your code, we have quite a few debuggers, very good parallel debugger. So AlineaDT, and we also have IBM supply tools, and obviously CUDA, GDB, CUDA memcheck, Valgrind memcheck, and others. So the profiling you can be done with HPC toolkit of Ampere, Tau, or other resources. You're probably also familiar with those if you have been developing on a big parallel machine. We also have development support of the heap or ROCm. So if you look into the direction of AMD, you probably would enjoy some tools available on Summit for that development work. Also, if you have a project which is machine learning heavy, we have some popular frameworks installed for you as a TensorFlow, PyTorch, different Python libraries, and also NVIDIA and IBM tools. For the visualization, you can use ParaView, VisitSite, and others. We also have quite a few workflow developed in-house, and they will be available for you. So you can also read the details in the user guide. And again, if you have something which is not in the list, you can always contact us, and we'll try to accommodate your request. So next slide. Next slide is about Frontier. Frontier will be a next machine coming next year. It will be available for those projects which apply for 2 or 3 years. So Frontier is still under NDA, so we cannot give you like details of the architecture, but what is available already, that the peak performance will be more than 1.5 exaflop, and it will be roughly 100 cabinets with heterogeneous nodes again, which will consists of AMD EPYC CPUs and for purpose-built AMD Radeon Instinct GPUs. The CPU and GPU will talk to each other through the AMD Infinite Fabric interconnect, and then the system interconnect will be a slingshot. So of course will be also a storage system mounted to this machine, which will be 2 to 4 times more capable than the current Summit I/O capabilities. So the information for the frontier is the link, which is on the bottom of that slide. So we'll continue with resources available at ALCF, and then Marta will introduce you to those resources.
Thanks, Dima. One of the production resources available to 2022 INCITE projects at the ALCF is Theta. You have the specification here. Is also the information available on the DOE website. It's an 11 petaflop integrated system consisting of 4,392 nodes with a second generation Intel Xeon Phi processor, which is code name is Icelandic, which KNL. You probably, some of you have used them. And the mission for Theta since the day one has been to facilitate the transition to the upcoming Aurora machine. And the idea was obviously to enable workflows at a larger scale, such as those involved in data and learning methods. Each node on Theta has 64 cores and a memory hierarchy consisting of 16 gigabytes of high bandwidth memory, 192 DDR4, and also you have the SSD, the 128 gigabytes of solid state drive, which can be particularly helpful for data-centric workflows. Theta's network is a Cray Aries high-speed interconnect in a Dragonfly topology. And as Catherine was mentioned at the beginning, one of the novelties is that you have 2 new file systems that are currently mounted to Theta, which are Grand and Eagle, both, each one with 100 petabytes. In addition to that, you have also access to Coolie, will be to facilitate analysis and visualization of your science runs. And also you have HPSS type archive in case it's necessary. Similar to last year, we are anticipating typical allocations for Theta to be between 1.5 and 2.5 million node hours. Next slide, please. Thank you. So the Cray programming environment is what you will see and you will find available on Theta, in addition to a number of other software, tools, and libraries that are presented here. You have a standard distributed and shared programming models are available like MPI and OpenMP. You have several C, C++, and Fortran compilers that are provided, as well as optimized libraries and debugging and performance analysis tools that are described in this slide and are also available on the website. Additionally, several software options are available for those projects with needs in the areas of data science, machine and deep learning and workflows, and many of them are currently provided as models that have been optimized on Theta. If your project workflow requires a specific computing environment, like for example, Singularity may be helpful as a containerd solution to load your software image onto Theta's compute node. And for complex workflows, which are involving large campaigns of jobs to be run with interdependencies, Balsam may be a solution for you to consider for your ensemble jobs. We highly encourage projects, particularly on the data science and AI variety, to check if your required software is currently available on the ALCF resources and to reach out to us if it's not clear. You have in each slide, in most of the time, you have a link to a web page, and feel free to contact us also. Next slide, please. Thank you. Polaris is one of the new resources. Catherine was mentioning it also at the beginning as novelty. So ALCF will be deploying this system in the summer of 2021 timeframe. And Polaris is planned to be a hybrid CPU and GPU machine that will be available to INCITE. I know that there are some questions on the chat. We can address them during the Q&A or in the next slides. The anticipated Polaris configuration is for a system with peak performance between 35 and 45 petaflops, and with a total system memory greater than 250 terabytes. Polaris will have also DDR and HBM as system memory types, and the node performance is supposed to be greater than 70 teraflops. This is the information that we have available in this slide and also at the website. We are expecting to have the compute nodes with composed of 1 CPU and 4 GPUs. And the system should have more than 500 nodes with node-to-node interconnect of 200 gigas. Next slide, please. As of now, this is the information that we can share regarding the programming models or the available software. So you are expected to see in this system, for example, for programming models, OpenMP 4.5 and OpenMP 5, SQL, Cocos, Raja, and HIP. And for performance and debugging tools, you will have obviously GPU tools available, PAPI, Tau, HPT Toolkit, which are currently used on the LCF systems, and obviously also debuggers like DDT. With respect to the available frameworks, for those who are interested in that front, we expect to have Python, Numba, TensorFlow, and PyTorch. Next slide, thank you. So coming soon to the ALCF is Aurora, an exascale architecture designed for simulation, data, and learning. A sustained double precision performance of more than 1 exaflop will be delivered by compute nodes, each having 2 Intel Xeon CPUs and 6 Xe Intel GPUs, all with unified shared memory. So similar to Frontier, Aurora's network will be the new HPE's slingshot fabric in Dragonfly topology, with multiple connections on each node. DEOS will be also a key component on Aurora, delivering performance I/O for the data-intensive workloads. And Aurora is expected to have more than 9,000 compute nodes with a node performance of more than 130 teraflops. Next slide, please. Thank you. So Aurora's software stack will consist of the HP Cray Xe software stack, Intel software, and a number of data and learning frameworks that are presented here that have been optimized for the Intel hardware. Additionally, several programming models and performance portable abstractions will be supported. Please check the website, which is down in this page, is aurora.alcf.anl.gov for the latest information on Aurora as it becomes publicly available. For proposals that are asking for 2 or 3 years, Aurora will be an allocable resource in 2023, and allocations at this time will be made on Theta equivalent node hours. So typical awards for Aurora are expected to be in the range of 40 to 50 million Theta equivalent node hours, and 2 and 3 years awarded projects will be required to revisit their allocation requests in future renewals. Please do reach out to us if you need assistance with estimates of the allocation on either outcoming exascale systems. Next, please. Thank you. So when considering whether your project is appropriate for the INCITE program, there are a handful of key questions that can be helpful to consider. So for example, is both the scale of the production runs and time demands of the problem of an LCF scale? So if the work you are proposing could easily be completed on a smaller scale computing resource, then the INCITE program might not be the right choice. However, if your resource allocation needs are substantially larger than what is available anywhere else, or your science runs are too large to run on another system, then the INCITE program might be a good fit. And another question that you can consider is whether there is a unique architectural or infrastructure resources that your work requires that are not available anywhere else. In addition to large-scale compute capabilities, like provided in general by the LCFs, very large memory or I/O performance demands might also be indicators of an INCITE appropriateness. It is also important to articulate in the proposal whether the team is in place to successfully carry out the proposed science campaigns. Next, please. Additional questions. So does your project have large data and AI needs? Have the strategy for workflow, data management, and post-processing been clearly identified? With regard to ensemble workflows, An important question to consider is how individual runs are coordinated. If you have ensembles that are running under the direction of a workflow manager with scalable I/O and on a parallel file system, then the ensemble is probably appropriate for the LCF resources. But if, on the other hand, the ensemble consists of a large number of independent, possibly serial batch jobs with no workflow coordination or efficient I/O strategy implemented, then the ensemble may not be appropriate for LCF resources. So that is an important element to consider too. Other questions. Do you have a plan in place for staging data into and out of the LCFs? Processing generated data. How are you going to archive data? And when appropriate, making data available to the community. How are you going to share your results? Providing answers to all of these questions in your proposal is especially helpful to reviewers for assessing the computational readiness of your projects. So if you have questions as to the appropriateness of the workflow you are considering for INCITE, please do reach out to us in the LCFs to discuss further. Next, please. Now we will begin discussing the outline of the proposal documents. In particular, we are going to focus on the project narrative in the next set of slides, which comprises, as Catherine was mentioning, the bulk of the INCITE proposal. Next, please. So getting started. An important thing to remember as you start crafting your proposals is that the INCITE program is very broad in scope. So members of the science panel, as mentioned in the previous slides, are drawn from national laboratories, universities, and industry from around the world. And you should not just assume that the reviewers are familiar with your specific work through other programs. The same is true of the computational scientists at the leadership computing facilities reviewing the computational readiness aspects of your INCITE proposal. So while the reviewers do have appropriate domain expertise, it's best to not assume that the reviewers are familiar with the specific work or the algorithms that you are using in your science campaigns. So the proposal should be written with a general audience computational scientist in mind. And remember that reviewers on the science panels will be assessing the potential impact of your work versus other submitted proposals. We encourage you to look at the reviewer questionnaires that are posted on the INCITE Call for Proposals website for additional guidelines. Next, please. This is the important element. The principal determinant of a successful INCITE proposal is the impact of the work proposed. This really cannot be stressed enough. It is critically important to provide a compelling picture of the impact of your science that is accessible to researchers in your field, as well as those that are outside of your area of expertise. Make sure that you explain the scientific challenges you are working to overcome, their significance and the impact of the work if the computational campaign is successful. And it's important to place the proposed research in the context of competing work in your field. So it is imperative to justify in your proposal also why the proposed work needs to be done today on LCF resources requested. Next, please. Keeping a general audience in mind, describe your approach to solving the science problem, along with challenging aspects of the work and any preliminary results. So the science should be your center. It is important to clearly map out how the requested resources will be used for key simulations to accomplish the key objectives that you are describing in the proposal, and to complete the project milestones that you are going to outline in the milestone table. So the provided plan, connecting resources to calculation in support of the milestones, should be clearly articulated for each year of the project. If you're asking for several years, each year should be specifically detailed. And do bear in mind that the average INCITE award of time for a single project is equivalent to several $1 million. Next, please. Thank you. When it comes to describing your computational approach, Please be sure to provide the basic foundation and key points pertaining to its formulation. Chances are high that the reviewers will be familiar with the relevant codes and the methods that you are presenting in your project or that you are using in your project. It is best to assume that is not the case. So be sure to show justification that the code you are planning to use is the correct one for your research plan, and do explain key differences if you plan to use a private modified version of a well-known code, for example. Make sure to check that all programming languages, libraries, and tools needed by your project are available on the systems that you are requesting the allocations on. And be sure to list all required software for your project, and note that sometimes, in some cases, users may need to install the software themselves if it's not available. If it's unclear whether some required software is installed on the resource you are requesting an allocation on, please feel free to reach out to us in the LCF for clarification. Next, please. Regarding data management plans, please be sure to describe your project requirements for input data, storage during and after your science runs, and the movement of data between LCFs and other sites. So do describe how long the data needs to reside on the project workspace, on the parallel file system, as well as also in the archive, and how those times were determined. Be sure to include a description of the long-term use for the data and any tools and infrastructure required to support your data needs. Also include descriptions of your AI, analytics, and visualization needs. That is also very important, workflows, and any software that you may need. Next, please. Regarding the narrative, it is also very important to provide detailed descriptions of your planned computational and data-intensive campaigns for each set of runs, whether they are exploratory, production, or post-analysis. Do describe all pertinent details, such as the number of runs, the number of nodes for a run, and the world time for each batch job submission. This is very important, also especially for the computational readiness as information that the reviewers are trying to understand. So I will encourage you to make sure that you follow these guidelines because this is probably what you want to make sure you want to emphasize: knowledge of your application and of the project. So in addition, you please describe IO-related details of your science campaign, including size, frequency of checkpoint files, size of the input and output data, and discuss also the performance where appropriate. For output data generated, discuss which resources would be needed to complete your analysis. For example, are the LCF resources, or maybe you're going to use a local workstation at your home institution. And to mention that the file transfer protocols or services that you will be using, for example, if you're going to use SCP or Globus or any other way to transfer the data. Please remember that the details really are important, and for proposed runs, be sure to describe the relationship to the project milestones as discussed in the narrative and the milestones table. So everything should be clearly explained and articulated. Next, please. The performance data provided in the proposal should support the required capability scale runs and be relevant to the proposed simulation data and science runs proposed. So be sure to discuss how efficient the applications make use of the specific architectural features, like, for example, the multiple GPUs for nodes on, per node on Summit, or the hardware threads and vector units on Theta. And it is best to generate application performance data on the resource you are requesting an allocation on. So, but similar site runs in other related resources can be also useful. To be clear about the number of nodes, the MPI ranks, the threads, or the GPUs that are used to generate the performance data, and that production style IO if it was used in the benchmark. Also describe the sources of any performance or scaling deficiencies and how your project plans will address them before or during the projects. Next, please. When presenting application performance data, it is best to pick the approach most relevant to each type of RAM in your proposed science campaign. So examples here of weak and strong scaling performance plots are presented in these left and right figures. When you see the x-axis is indicating the number of nodes, and the time to solution is plotted on the y-axis. So these weak and strong scaling performance data for the applications are used to generate and are very, very useful to the reviewers. And they show representative inputs and production. You should be presenting them or providing the information of production style settings, which is the most relevant data to show in your proposal. So try to make sure that this corresponds to the case that you will be running. Obviously, you cannot run the whole simulation, but at least most of you will have already the case prepared and tested initially. So it's very important to have these graphs. For each proposed application, plot the performance metric that is most appropriate for your workload. So you have different cases, different codes, obviously. You can add different plots. And be sure to also discuss node level efficiencies and indicate any resources that are most important for your project needs. Next, please. Thank you. If the work you plan to propose consists of a large collection of independent and loosely coupled calculations, Catherine was already mentioned ensemble or community umbrellas, then, so in this case, it can be helpful to discuss the computational intensity of that workload. So if the size of the ensemble is such that a reasonable time to solution can only be achieved by running on a large scale resource and the volume of the work is facilitated by the workflow manager, then the ensemble you're proposing is likely appropriate for INCITE. However, if the members of an ensemble could effectively be carried out on a smaller scale resources, like with a reasonable time to solution in a smaller institution, for example, then the ensemble may not be appropriate for INCITE. So these are the kind of questions that you may have if you are planning to submit any request related with ensemble. And we encourage all projects considering ensemble workflows to refer to the frequently asked questions. In this case, it's number 33 in the DOE leadership website. And as well as obviously reach out to us in the LCF to discuss your project plans. Next, please. Thank you. So in a few words, in the interest of time, about data and AI applications. So in addition to traditional computational intensive simulation projects, the INCITE program is encouraging and supports data and AI campaigns. So proposals in this area should contain strong aspects of scalable data processing and or employ AI methods at the scale of the leadership computing resources. The examples of capabilities employed by data and AI projects are included here. For example, machine and deep learning, data-intensive computing, you have a list. While many areas might be shown, this list is obviously not complete and will surely continue to grow as large-scale data and AI capabilities continue to mature. The INCITE program does indeed receive strong proposals having significant data and or AI components. And as mentioned earlier, these proposals are evaluated by a data and AI panel. Next, please. Thank you. The recipe for success when it comes to a data and AI-centric proposal is really not different than that from a traditional simulation proposal. So proposals should be clear and should articulate clearly the objective of the planned work and provide details on dependencies for the complete end-to-end research campaign. A full list of applications that require and should be provided in the proposal, including as appropriate, database, learning frameworks, workflow managers, container solutions, and so on. Any detail that you are aware that could be relevant, please do share it. So it is best to generate performance data for the data and AI workflow that is demonstrating can run efficiently at scale on the resources requested. So for this reason, in general, it is especially beneficial to PIs considering these kind of proposals to request a director discretionary allocation at one of the centers, especially in order to address any challenge that may arise in your end-to-end workflow ahead of time. And when generating benchmark data for your proposal, it is important that the generated data is representative, as we mentioned in the other cases, of production science runs, and that the models are those expected to be run in production. So additionally, proposals that couple elements of simulation, data analysis, and AI, as Catherine was mentioning initially, are certainly encouraged. And with that, I will pass it back to Dima.
Okay, thanks, Marta. So we'll continue with the narrative, and there's only a few points we'll have to cover, and we are in the top of the hour, but I'll speed up a little bit. So one part of the narrative is the development work. So the most important point here is to remember that it's totally fine to have a development component in your INCITE proposal. But if you choose to do that, please also provide milestones which are dependent on that development work and how they develop. And how they depend on that work. Also, if you choose to do some development work, estimate the computational resources you would need to conduct that work, and please do include them, those estimations in your allocation request. Okay, next one. Okay, the next one is the management plan. Management plan is a part of INCITE proposal, and where the experience of the team, credibility of the work proposed, and transparent use of requested time should be reflected. So thus, please list the scientific and technical members, as well as their experience in relation to the proposed scientific campaign. So successful team would demonstrate knowledge and efficient use of HPC computing resources in accomplishing scientific and technical goals. So importantly, project involving multiple teams or different thrust areas should clearly state how the allocation will be distributed and managed between those teams and thrusts. So also, please do include personal justification in as a brief description.
What time? Okay.
Looks like somebody's broadcasting. Okay, it's gone. So yeah, again, the tip is here is to include personal justification, a brief description of the role of each member on the team. Although it's not a requirement, the proposal with application developers or clear connection to development teams are favorably viewed by the readiness reviewers. All right, next one. Okay, next one is a milestone table, and it's important to understand that milestone table is an integral part of the INCITE. So basically, if you're not submitting the milestone table, the proposal won't be reviewed. So please, the easiest way is just to use the available on the web page template, and just follow that template. But basically, what you would need to have in your milestone table is the computing resources and allocation request in node hours, file system and archival storage and duration, software application deployed, summary and computational tasks, dependencies on or between those milestones, and expected start, target, completion date, and the status in between. So that's the milestone table, and the next point will be the INCITE publication. Next slide. INCITE publications, they are very important. I mean, obviously, for you as a user, as a representative of the scientific community, to document your scientific work and achievements. But they're also very important for us as a facility, because we have to report back to our sponsor, to DOE, to other users, to showcase the INCITE program, as well as to general public, because we also write general public announcements and reviews on the work which is conducted at the INCITE projects. So please do include those publications which are resulted from the previous year's INCITE allocations and awards. So that covers publications, and the next slide will be the timeline. So the timeline for the INCITE is illustrated here, and there are like three main phases. The first one is solicitation and review, the next one is selection and award, and then last one is access, getting access and monitoring the progress. So obviously we are currently at the solicitation period, which will last until approximately mid-June. So this time is always shift, as Catherine already made you aware. This year is June 18, but please also always check on the submission web page what is the actual date for this particular year. So right after the solicitation, a computational readiness review process starts. This process will be followed closely by external scientific panel review, which starts usually like in second part of August and September. So after that, we have the selection phase, so selection time, where the both facilities will hold meetings and will decide based on the outcome of the peer review which proposal will be granted. Then awards usually come in the beginning of November. Then we'll start the access processing. So the facility will contact you. You will get all the technical details figured out, and then everything will be fine, and you'll get your access on January. And from that point, you'll run and we'll also just write your periodically reports and consume your allocation, hopefully successfully generating new science. All right, so the annual timeline is covered. Next one is about if you're asking yourself like, so am I ready to apply now? And there are a couple of points which can help you to decide. So first of all, is the code ported before submitting proposal? Yeah, so if you are going to use community software, check if HPC ready or GPU or GPU accelerated version available from the developers. So if you are the developer of your own software, then request a startup account if needed for development and benchmarking runs on the resource you are requesting in your INCITE proposal. So the second point is completing benchmark data. So is the benchmark data generated? So prove application scalability in your proposal. So run productive scale examples relevant to the proposed work. So that already has been stressed many times, but Marta was mentioning that. So it's very important that you're actually targeting a production scale or close to that, and also a problem, a scientific problem, which is relevant to your INCITE proposal. Okay, the next one. How to request a startup account now. So this startup account is a means of helping to prepare for the INCITE proposal for the users. So those allocations are called director discretionary, DD for short, projects, with primary goal of porting, tuning, scaling up codes in preparation for the INCITE submission. So you may request a DD allocation anytime during the year, and the process is very straightforward and very simple. So we always encourage users to submit DD at least 2 months before INCITE call for the proposal closes. So basically this means if you would still like to submit INCITE this year, you most likely should have gotten your data already or be really in the middle or final stages of generating your benchmark data. So, but if you plan for submitting next year INCITE, so it's a very good time to write a DD proposal. So it's very informal again, and all the details are in those 2 links for each facility you see at the bottom of this slide. Okay, so this covers the DD. Next slide is it's just a check of the narrative. If you have all the components needed for the submission of the INCITE. So you have to have the executive summary, 1 page, the project narrative, including impact of the work, objectives, and benchmarking. So that's the body of the proposal. So it's 15 pages. Then you have to have personal justification and management plan, milestone table, publication resulting from the INCITE awards, and then the biographical sketches. So I guess with that, we arrived at the end of our presentation. I'll get back to Catherine. She'll probably give you some final remarks, and then the floor will be open for the questions. Thank you.